Good morning, students. Class 12th, chapter number 6, applications of derivative, lecture number 14, homework, and lecture 15. So you were given miscellaneous exercise to complete in your homework notebooks. Let us discuss some of the questions from the same exercise. So I'm going to start with miscellaneous exercise question number 12. Question number 12 has been repeated in CBSE and is an important question. In the question, it is said that a point on the hypotenuse of a triangle, as they are talking of hypotenuse, we should draw a right angle triangle, right? So let us just draw that first. Let us make this angle as 90 degree. Okay, let us now just name it A, B, C. So what are they saying? A point on hypotenuse of a triangle. So on this hypotenuse, I'm going to take any point, let it be point P, is at a distance of A and B from the sides of the triangle. That means the distance of this point from either of the side is A. Let us just take it. Let this be A and let this be B. This is the distance. So naming this as A, this is B. You can also name this one as, suppose I name it as PN and PM. So you can call PN as B and PM as A, right? It doesn't matter. Accordingly, you will be getting your answer. Now they are saying, show that the minimum length of the hypotenuse is this. So what is the thing that we have to do? AC, which is the hypotenuse, will be equal to AP plus PC. So our purpose is to minimize this. Now to minimize this, the second order derivative of this hypotenuse, right, should be greater than 0. It should come out as positive. Now let us just try to find out AP. You see in the triangle A and P, this angle theta, and in this triangle ABC, this angle theta. They both are same because the line NP and BC are parallel to each other, right? So now just to see, what about if we see in triangle ANP? Okay, what is ANP now? See, you have to use this and you have the side this. So you see in front of 90 degree, whatever will be there, that will be your hypotenuse. So you have hypotenuse and the side adjacent to the angle theta, which is A. So you have base. So we can use cos theta. You can write that cos theta is equal to base, which is A, upon the hypotenuse, which is AP. It is PMC. Just to see in this, we have the side opposite to angle theta and the side, this one PC, which is the hypotenuse. So just to see, we can write sine theta would be equal to, so sine theta will be the ratio of side opposite to angle theta, which is B, divided by the hypotenuse, which is PC, right? So we can calculate the value of AP and PC from here. So what will be AP equal to A divided by cos theta, which can also be written as A secant theta. Okay, now doing the another side, what will be PC equal to? B divided by sine theta, which can further be written as PC equals B cosec theta, right? Now we have got the side AP in terms of theta as well as PC in terms of theta. Let us just write this all on a separate page and do it. So AC is AP plus PC, where we are getting AP as A secant theta and PC as B cosec theta. Okay, so this is our AC in terms of theta. Now theta can be any value. We'll differentiate this with respect to theta. So let us just consider and represent it with Z, or because it is a length, let us take it as capital L. Differentiating it with respect to theta, we will get dl by d theta equal to A as it is. Differentiation of secant theta will be secant theta into tan theta, and of theta it will be 1 with respect to theta, plus B cosecant theta will be minus cosec theta into cot theta. So what we have? A sec theta into tan theta minus B cosec theta into cot theta. Now for the critical point, we put the first order derivative as equal to 0. Putting this as equal to 0, we have A sec theta into tan theta. Okay, putting this is equal to 0, we can just transpose this term onto another side. We will get b cosec theta into cot theta. Right. Now let us just find out the value. So we have b divided by a equals secant theta into tan theta divided by cosec theta into cot theta. So just to solving it, what do we get? Just see carefully. We will get, see, secant is 1 upon cos, cosec is 1 upon sine, so it will come in the numerator, into tan theta into 1 upon cot theta. Now we know b divided by a will be equal to sine theta upon cos theta is tan theta multiplied with tan theta, and 1 upon cot theta is also tan theta. So we have tan cube theta. So writing it as tan cube theta as equal to b divided by a. We have tan theta value as b divided by a to the power 1 by 3. Let us name it as our first equation. That is our critical point we have got. Now just to see, what was first order derivative? This was a secant theta into tan theta minus b cosec theta into cot theta. Let us differentiate it again, because we have to prove the second order derivative as greater than 0, because we want the minimum value. We have to minimize the function. So let us just do that. So our dl by d theta was equal to a secant theta tan theta minus b cosec theta into cot theta. Differentiating it again with respect to theta, we can see we have two functions. So we'll use product rule. A secant theta, suppose it is as it is, we are keeping tan theta, it will be secant square theta, okay, plus tan theta as it is, and differentiation of secant theta is secant theta into tan theta. So it will become tan square theta into secant theta, right, minus b cosec theta as it is. Differentiation of cot theta is minus cosec square theta, so it will be cosec cube, plus now we will use cosec theta as it is. Differentiation of cot theta is minus cosec theta into cot theta, so it will become minus cot square theta into cosec theta, right. Just now see, multiply the constant inside, a, okay, secant cube theta, okay, plus a tan square theta secant theta, minus b, minus minus plus b cosecant cube theta plus b cot square theta cosec theta. Okay, now a, in these two what is common? A and secant theta. Secant theta into, here we will be left with secant square theta plus tan square theta plus b cosec theta into cosec square theta, and this complete value is going to be positive at every value of theta, right. So second order derivative is going to be greater than 0. So we say this point is a point of minima. Now we have to find out minimum hypotenuse. So finding out the hypotenuse, it was AC equal to AP plus PC, where AP was equal to A secant theta and PC was equal to B cosec theta. Now we know the value of tan theta, which is b divided by a whole to the power as 1 divided by 3. So from here we can actually calculate what is tan theta now if I separate the power b to the power 1 by 3 and a to the power 1 by 3. We know tan theta is the ratio of the perpendicular and the base, or the opposite side and the adjacent side, if this is theta. So we have b to the power 1 by 3 and a to the power 1 by 3. Correct. So we can find out hypotenuse just solving it for you here. So b to the power 1 by 3 whole square plus a to the power 1 by 3 whole square will be equal to this hypotenuse square. Correct. So what is hypotenuse equal to now? Square root of b to the power 2 by 3 plus a to the power 2 by 3. I have multiplied this 2, the square, with 1 by 3. Correct. So this is the hypotenuse. Now what will be sine theta from here? Sine theta will be perpendicular, the side opposite to it is b to the power 1 divided by 3 divided by square root of a to the power 2 by 3 plus b to the power 2 by 3. Similarly, if we know sine theta, we can find out cosecant theta. It will be reciprocal of it. Similarly, cos theta will be a to the power 2 divided by 3 divided by the same hypotenuse, which is a to the power 2 by 3 plus b to the power 2 by 3. Now I'm going to place the values in AP. AP is what? A secant theta, right? Just look the value for cos. For cos we have this. After reciprocal, the value of cos theta we have A multiplied with a to the power 2 by 3 plus b to the power 2 by 3, its square root, divided by a to the power 1 by 3. Now PC will be b cosecant theta. So PC is written as b square root of a to the power 2 by 3 plus b to the power 2 by 3 divided by b to the power 1 by 3. Just see carefully, these were the only values, so we have taken the reciprocal of them. Now finding out the hypotenuse, AC will be equal to the summation of these two, right? So we have we can take a to the power 2 by 3 plus b to the power 2 by 3 square root common, and we have inside the bracket, because we are adding these two, so we have a to the power 1 minus 1 by 3. Just to see, this can be solved like this. Similarly, here also we can subtract the powers, so plus b to the power 1 minus 1 by 3. So just see what we have. Square root of a to the power 2 by 3 plus b to the power 2 by 3 multiplied with a to the power 1 minus 1 by 3 is 2 by 3 plus b to the power 2 by 3. Clear? Now we can add the powers. Its power is half, its power is 1. The bases are same. So just see, we can write it as a to the power 2 by 3 plus b to the power 2 by 3 half plus 1, which gives us a to the power 2 by 3 plus b to the power 2 by 3 whole power as 3 divided by 2. Correct. So what we have got, this is the minimum length of the hypotenuse. I'm again repeating the question for you, what we have done. So in the question it was given to you that a hypotenuse is there of the triangle on which a point is taken, and the point is at distance A and B as shown in the diagram. You can see, right? We took point P, and PN and PM are the perpendiculars, and one distance is A, another one is B. Using trigonometric identities, or I say the ratios, we have found out the value of AP and PC in terms of theta. Then we added them and started differentiating respect to theta, which is here as you can see. So after differentiating it, we put that equal to 0, and we got that tan cube of theta as equal to b divided by a, and then we got tan theta. The second order derivative is going to come as greater than 0, which is positive. So at this value, now we have to find the minimum length. So the length is like this, AP plus PC. Putting the values from tan theta of sine theta and cos theta in the expression, we got the value or the minimum length of the hypotenuse. Clear? So this is how you are going to solve question number 12. It is important to give it a try 2 or 3 times in your notebooks. You can use another methods also to prove this. Alright, this is just one way of proving it. Let us go to another question. Here comes next question, question number 13. In 13th, we have to find the points at which the function f given by f of x. So I'm writing the function here, x minus 2 to the power 4 and x plus 1 whole power is 3, has local maxima, local minima and point of inflection. So we have to find out the points. So to find out the point, we are going to differentiate it. To differentiate it, we will use product rule. So f dash x will be equal to, first of all I'm keeping x minus 2 to the power 4 as it is. Differentiation of x plus 1 whole cube will be 3 x plus 1 square, and differentiation of x plus 1 will be 1 only, plus x plus 1 whole cube as it is. Differentiation of x minus 2 to the power 4 is 4 x minus 2 whole cube, and differentiation of x minus 2 is 1. So just say what is common here. We can take x minus 2 cube common. We can take x plus 1 square common. So what we are left inside the bracket? We are left with 3x minus 2 plus 4x plus 1. So just to see, we have x minus 2 whole cube, x plus 1 whole square, and here we have 3x minus 6 plus 4x plus 4. So we have x minus 2 whole cube, x plus 1 square, 3x plus 4x is 7x, and 6 minus 6 plus 4 is minus 2. Right? To find out the critical points, which we will be finding whether those points are of maxima, minima or inflection, we will equate it to 0. Equating it to 0, we have the values of x as 2, x as minus 1 and x as 2 divided by 7. So these are the 3 points. Now how do we check that these points are of maxima, minima or point of inflection? So we will use first order derivative test. Just to see, I am not going to solve the complete. I'll solve for one. We'll show you how it works. Okay. So what you have to do is, you have to write the value f dash x here. You write the point here. Okay. So we have the point x as 2, x as minus 1, x as 2 divided by 7. So you are going to write the nature of f dash x. Okay. Here we will write the nature f dash x, whether it is changing sign or not, and what it will be, that the point of maxima, minima. Okay, nature of point you can write. Okay, so at x equal to 2. Now for x equal to 2, I'm showing you here what can be done. You can do the same for another questions also, or the another points. Just to see here. Let us write the first order derivative here. What is first order derivative that we got? This is first order derivative, x minus 2 whole cube, x plus 1 whole square, 7x minus 2. Let us write that. So we have x plus 1 whole square, x minus 2 whole cube and 2x minus 7. So a value less than 2. Okay, when x is less than 2. So suppose if we put a value less than 2, let us consider it as 1.1. Okay, or anything that you can take. So suppose we take it as 1 for easy calculation. Okay, so less than 2 is 1. So 1 plus 1 whole square, 1 minus 2 whole cube and 2 into 1 minus 7. So see, 2 square positive. Okay, 1 minus 2 is minus 1 whole cube negative, and 2 minus 7, which is minus 5. Correct. So we have 4 minus 1 minus 5. So we minus minus will be plus. So we get it as greater than 0, or I say positive. Now take x as greater than 2. First we took x as less than 2. So for greater than 2, just to see, suppose we take 3 as the value. So 3 plus 1 will be 4 multiplied with 3 minus 2 is 1. 1 whole cube will be 1 into 2 into 3 is 6. 6 minus 7 is minus 1. So see, we are getting negative answer. So what is happening from positive to negative? So this point will be of maxima. So you will write here f dash x changes from positive to negative. So nature of point is point of maxima. Clear? Now you will check for minus 1. Just put a value less than minus 1 and greater than minus 1 in the function. Find out whether it is changing sign, and if it does not change the sign at all, you say that point is a point of inflection. Similarly, check for 2 divided by 7. Clear? This is how we are going to do and identify the points. Clear? Very easy. First of all, we did the differentiation. Then putting that as equal to 0, we found out critical points, and then at those, using the first order derivative test, we are calculating whether the point is the point of maxima, minima or inflection. In question 15, we have to show that altitude, that means the height of a right circular cone whose volume is maximum. So one thing that we have to maximize is volume, which is 1 upon 3 pi r square h. Okay, that can be inscribed in a sphere. That means cone is inscribed inside a sphere whose radius is r. small r. So I have taken the radius of cone as capital R and height as capital H. So let us just look on this diagram. I have drawn a sphere inside which a cone is there, and the radius of the sphere is small r and the radius of the cone is capital R. The height of the altitude of the cone is capital H. So if this is r, this is r, this I'm talking of this and this. So this will be what? This complete is capital H. This is small r. So this portion, if I name it as OM, this will be H minus R. So just to see, if I apply in this triangle AMO, in the triangle AMO, we can write using the Pythagoras theorem that small r square is equal to capital R square plus H minus R whole square. So what we get is R square equals R square plus H square plus small r square minus 2HR. Right? R square and R square getting cancelled. So what is the value of R square from here that we get is? We get it as 2HR minus H square. Getting it? Keeping R square on one side and shifting the other two terms onto another side, I get it as 2HR minus H square. This is the value of R square. I can place this value here. Clear? So let us just put in the formula of volume. So volume is 1 upon 3 pi R square H. So volume will be equal to 1 upon 3 pi. What is R square? 2 HR H square into H. Just to see now, we have 1 upon 3 pi. Multiplying this H inside, we have 2H square R minus H cube. Now we will differentiate it with respect to H. The volume of cone does not depend on volume of sphere. It depends on the radius and side of the cone only. Let us now differentiate with respect to H. So we get dV by dH equals 1 upon 3 pi as it is, 2R as it is. Differentiation of H square is 2H minus 3H square. Now we will put it as equal to 0. First of all, simplify it as we can. So we can write 4RH minus 3H square equals 0. Okay, just to see now, if we put it as equal to 0, 1 upon 3 pi, what is common in both of them? H is common, correct? So what we are left with, 4R minus 3H equals 0. So either H is equal to 0. So height definitely can't be 0 of the cone. And from here 4R equal to 3H. So here we get capital H is equal to 4R upon 3. That means height of the cone is 4R upon 3. Just see here. Here we have to prove the altitude of the cone as 4R upon 3, where R is the radius of sphere, and that we have proved. But along with that, we have to prove the volume of the cone as maximum. To do that, what we will do is find out the second order derivative. Finding out the second order derivative here itself, just to see what we will get. So first order derivative is here in front of us. This is first order derivative. Putting it as d square v upon dh square, we get the answer as equal to 1 upon 3 pi as it is, right? 4RH differentiation will be 4R minus 6H. Now instead of H, we will put 4R upon 3. So 1 upon 3 pi 4R minus 6 multiplied with 4R upon 3. So 3 2s are 6. 4R minus 8R is minus 4R, which is less than 0. So we see the volume of the cone is maximum when the altitude of the cone is 4 upon 3 times the radius of sphere, which is small r. Clear? I hope you can understand the question and can redo it in your notebook without having a look on the solution now. So let us and try to do questions of maximum minimum with your own method. Right? I have used Pythagoras theorem. You may use the vertical angle of the cone, semi-vertical angle of the cone like this. So you can try different ways of doing it. Fine. Let us do another question now. Here comes the next question, question number 18. In question number 18, in this question, we have to show that the height of cylinder of greatest volume which can be inscribed in a circular cone. So first of all, we will draw a cone. So let us just draw it, and we have to inscribe what? A cylinder inside it. So if I draw a cone, so as you can see, there is a cylinder which is inside this right circular cone of height h. So height h is of what? Show that height of cylinder of greatest volume which can be inscribed in a cone of height h. So this small h is the height of cone. So that means this is, I can represent it with the line, this complete, right? This is the height and this is given as equal to small h. This is small h for us. So let us just assume the height of the cylinder as capital H. So let us just represent it like this. This is suppose capital H. Clear? Now what we have to do, semi-vertical angle is given as alpha. This angle is alpha. Is 1/3, that means height of the greatest volume of cylinder. So capital H should be, that can be inscribed in a cone whose height is small h and semi-vertical angle is alpha, is 1/3 of the cone. 1/3 of the height of the cone. So this is what we have to prove. I am again reading the statement. Height of cylinder, which is capital H, of greatest volume. So one thing that we have to prove as greatest is the volume, which is of obviously the cylinder. It is mentioned in the first line. So pi r square h. Let us take the radius as capital R for cylinder. Clear? So this is there now. And now what we have to prove, that the volume, greatest volume will be this much, 4/27 pi h cube 10 square alpha. So what we will do is, we can differentiate this, but we should have this only in one term. Also we have make use of the given angle which is alpha here. So making use of it, what I can write is that in the triangle, suppose I name it as AMB. So in triangle AMB, okay, what we have, tan alpha will be equal to this angle, because I have to make use of this angle. This angle will be equal to, see, the side opposite to this angle will be the perpendicular, that means this R divided by this much AM. What is AM measurement? Complete AC is small h, this MC is h. So what is this left for? Small h minus capital H. So R upon small h minus capital H. So what is R from here? Tan alpha multiplied with h minus capital H. What will be R square? H minus h whole square 10 square alpha. So what I can do is, I can place the value of R square in the volume. So what we will get? Volume is pi R square h. So volume will be equal to pi R square, we will write small h minus capital H whole square, and 10 square alpha into capital H. So just say V is equal to pi 10 square alpha. These are the given quantities, these are constants. Now if we solve it, we get h square plus capital H square minus 2h into capital H and h. We can multiply this inside so that we don't have to use the product rule, and directly we can simplify it. So we get h square h plus h cube minus 2h h square. Clear? Differentiating it with respect to capital H, because small h is the cone dimension, which is height, and volume is of cylinder, which depends on capital H, right? So pi 10 square alpha as it is, and then we have h square as it is, so we get h square. H differentiation with respect to h will be 1, plus differentiation of h cube will be 3h square minus, now what is here? 2h as it is, differentiation of h square is 2h, so we have 4h, right? This is what we have. Now we will put it as equal to 0. Putting this as equal to 0, just see what do we have is h square plus 3h square equals 4 times h. Clear? Also we can do what? We can take this h this side. So we will have 3h square minus 4h plus h square. We can factorize it by doing the method of splitting the middle term. So 3h square minus, we can write it as 3h minus h plus h square equals 0. So taking 3h common from the first two terms, we have capital H minus small h plus, or we can take minus h common. Just to see here, minus of h common. So we have h minus h here. Taking h minus h as common, the another factor is 3h minus h equals 0. So from this, see, h equals h. This is not possible. The height of the cone cannot be equal to the cylinder. The cylinder is inscribed inside it. Definitely it will be smaller. So this is negligible. 3h is equal to h. So capital H, which is the height of cylinder, is coming as 1/3 of the height of cone. That is one thing that we had to prove. Now, using the second order derivative, we also have to prove the volume as maximum of the cylinder. So what is the first order derivative that we are getting? We are getting this as the first order derivative. Okay, so using it we will find out second order derivative. Let us find that out. So we will get d square v by dh square is equal to pi 10 square alpha as it is, and here what we will get is h square differentiation is 0. 3h square will be 6h minus 4h. Now we have got capital H as 1/3 of h. If we put that, just to see, pi 10 square alpha, 6 multiplied with 1/3h minus 4h. So 3 2s are 6, 2h minus 4h. We are going to get the answer as negative, which is less than 0. That means the volume is maximum at this point. H equals 1/3 of height of the cone. Clear? Now the last thing that we have to prove is that we need to write the maximum volume. So the maximum volume will be by putting the value of capital H as 1/3h. We get pi 10 square alpha h minus 1/3h whole square into 1/3h. So just see what we get is pi 10 square alpha. Now 3h minus h is 2h upon 3 whole square into 1/3h. So we get it as pi 10 square alpha multiplied with 4h cube upon 3 3s are 9 3s are 27. So we can write it as 4/27 pi 10 square alpha h cube. So let us just have a look on the question and see if this was what we had to prove. Clear? As you can see, we had to prove the volume as, or the maximum volume as, 4/27 pi h cube 10 square alpha, which is what we are getting. So we have proved it. Clear? Let us go to another question now. In question number 21, it is given that the line y equals mx plus 1. This is a tangent to this curve. Okay, so if this is a tangent to this curve, the slope of this should be equal. So the curve is y square equals 4x. Let us first draw the diagram. As you can see, y square equals 4 will be a parabola, right, along x-axis, and then we have to take y equals mx plus 1 as a tangent to this curve. Clear? Now let us suppose the point on which this tangent is made is h comma k. So definitely it is going to satisfy the equation. So we can write that k square equals 4h. Let this be our first equation. Okay. Now y equals mx plus 1. From here dy by dx will be equal to m. Clear? Now differentiating this, we have 2y dy by dx equal to 4. So dy by dx is equal to 4/2y, or we can say it as 2/y. So now what is the point at which point the tangent is drawn? H comma k. So the slope will be 2/k. So the value of m, as we know, second and third are both the slope of tangent, we can write from second and third, we can write that m is equal to 2/k. Right, now we have to find the value of m as a numerical value. So first of all, we should either find h and k. Right, so to find out h and k, just think carefully. The equation is k square equals 4h and the slope is coming as 2/k. Any other thing that we can use in the question, just to see, y is equal to mx plus 1. So just look here carefully. Y is equal to mx plus 1. So now the tangent is drawn on this point h comma k. So we can write k is equal to mh plus 1. Right? Or k is equal to, what is the value of m that we are getting? 2 divided by k, h plus 1. Clear? This is what we are getting. Also, we had the equation k square equals to 4x for h actually. So we can put the value of h from here, which is k square by 4. Clear? If we do that, we get k equals 2 divided by k multiplied with h is equal to k square divided by 4 plus 1. K and k is getting cancelled. So what we have is, and 2 ones are 2 twos are. So we have k equals k divided by 2 plus 1. So just to see what we will get, k minus k divided by 2 is equal to 1. So what we get is 2k minus k is k divided by 2 equals 1. So what is the value of k from here is 2. Now to find out h, if we put here, what we will get is k square equals 4 multiplied with h. So 2 square will become 4, 4 multiplied with h. So what is h from here? It is 1. So we got k as equal to 2 and h as equal to 1. So the slope value was m equals 2 divided by k. Putting the value of k as equal to 2, we get the slope value as 1. Hence the A option will be correct answer. In question number 24, we have to find the points on this curve where the normal to the curve make equal intercepts on the axis. So just drawing out a rough diagram for you. So suppose this is our x-axis and y-axis, right? I'll just draw it a bit straight. So these are our axes and making the curve now. So the curve is, see, 9y square equals x cube. So it will be kind of like this. Now what is the question? Where the normal to the curve? So we have to make a normal. So suppose at any point you draw out a tangent, so you have to draw a normal, and that normal is making what? Equal intercept on the axis. So suppose this is the normal. Okay, because see, tangent would be somewhere here. And normal is what? Perpendicular to the tangent. Clear? So if this is the normal, I'm just drawing the normal. So suppose this point is, these are the two intercepts and intercepts are equal. Suppose this is a, this is also a. So 0 comma a, and this will be 0 comma or a comma 0. So what will be the equation of this line L1? It is a normal line. So equation of normal will be x upon a plus y upon a equals 1. This is the intercept form of the line already done in class 11th. So x plus y is equal to a. We get y is equal to minus x plus a. So what is the slope of normal from here? It is minus 1. Okay? Because it is of the form y equals mx plus c, and the value of m here is minus 1. Now the another thing that you should point out here is that we have to find the points on the curve. Right? So let us now see, this is slope according to this line and intercept. Now according to the curve, which is 9y square equals x cube, I'll write 9y square equals x cube. If I find out the slope from here, 9 into 2y dy by dx equals 3x square. So what is dy by dx from here? 3x square upon 18y. So we get 6. So x square upon 6y. This is the slope of tangent. What will be the slope of normal? Let us say that it is m1, or let us just represent it m, because we have already written m as the slope of normal. So m will be minus 6y upon x square. Now we know we have calculated the slope as minus 1. Keeping them two equal, we get 6y as equal to x square. Now putting this value of x square here, we can get 9y square is equal to 6y whole cube, right? Or to simplify the calculations, what we can do is we can write y as equal to x square divided by 6. Just let us put it. 9y square is equal to, putting y as equal to x square upon 6, we get 9 multiplied with x to the power 4 upon 36 equals x square. Cancelling the term, x is equal to 4. If x is 4, can we find the value of y from here? Definitely we can find it. So just look carefully. I'll be just doing it here. So y is equal to 9y square is equal to x cube. So putting x as equal to 9y square, x as equal to 4, 4 cube will be 64. So y square will be 64 upon 9 and y will be equal to plus minus 8 upon 3. So we have the answer as 4 comma plus minus 8 upon 3. Let us see which is this option. So going to the question, we see this is 4 comma plus minus 8 by 3 we are getting. This is option number A. So A is the correct answer for question number 24. So in homework, what you are going to do is you will complete chapter number 6 in your notebooks and revise it, because tomorrow you are going to get a revision lecture in which I will be telling in brief all the concepts, and then you can go through the questions well and get ready for the test. So for more videos, do subscribe the channel at Quark. Thank you.